And I'm going to record to the cloud. All right. All right. So can I ask Lindsay, Rachel, and Christopher to turn on your cameras if you could, so the audience could see you. I see Christopher there. There's Rachel and there's Lindsay. All right. So for this panel session, what we thought we would do was basically give you a chance to talk to and ask questions of three individuals who are involved in the type of STEM areas that NASA is interested in. We have an astrophysicist, we have a, I guess, Air Force pilot or test pilot, and an engineer. So Professor Lindsay Glesener, I guess you'll go first, and then it will be Christopher Gosch, who is an engineer and will tell us a little bit about himself. And then Major Winiecki will be the last one, and then we'll open it up for whatever questions you have to ask them to see how they got from where they were when they were students to where they are now. With that, I'll let you go, Lindsay. Tell us a little bit about yourself and about what you do and how you got to where you are.
Okay, sounds good. And just so that I make sure I don't go over the parameters you've got set here, what I'm understanding is that I should take just a few minutes for an introduction, right?
I'd say 5-10 minutes if you want to. If it's less than that, that's fine too.
Okay, great. Sounds good.
Not 5-10 minutes. Go with the 5 minutes.
Okay, since I'm a physicist, I will take the average of those two and I will go with exactly 5. So what I'd like to tell you about first is a little bit about how I got to where I am. And then I'm going to tell you a little bit more about what I do in my current job, which is, as Debo said, an astrophysicist. But it didn't start out that way. I was not one of those people who knew from the time that they were born that they wanted to be an astronomer or scientist or astrophysicist and just took a straight road towards that path. My road to getting to this particular career took a lot of twists and turns along the way. So I actually had a first career as a professional ballet dancer. That was literally half a lifetime ago, so it was a very long time ago. And that was my first career. Now, at some point, I realized that this wasn't what I wanted to be doing for the long term. And so I stopped that and went to school. And as I think many people do, I had a lot of trouble in school figuring out exactly what it was that I wanted to be studying. So I personally tried a bunch of different majors. I tried a bunch of different schools before I really found something that stuck. I think I was an education major for a while, and I was a psychology major for a while as well. But once I found physics, then I knew I was home. And then I really felt like I had found the thing that I wanted to be working on long term. And a lot of the reasons for that was because physics was both extremely interesting to me, but it was also extremely challenging. And although that was hard sometimes, it was also part of the appeal. There were tough problems here to solve, and I wanted to be part of the community of people working on those problems. So once I figured that out, I did stay in school long enough to actually get a degree this time. And I graduated from San Francisco State University in California. After that, I went to grad school at the University of California, Berkeley. And there again, it took me a little bit of time before I found what it was that I really wanted to work on. I knew now that I wanted to do physics, but I didn't know what kind of physics that I wanted to do. And I'll tell you that there is a lot of cool stuff out there. So picking which problems are the interesting ones that you want to work on can be a bit of a tough chore. So eventually I came around to astrophysics of a very specific kind, studying our sun. So I'm a solar astrophysicist, and that means that I spend most of my time looking at data and analyzing data that is from our sun. It's one of the closest astronomical objects that you can look at. And we, meaning the solar physics community, are looking at a lot of interesting things about the sun that you'd sort of think we'd have it all figured out by now, but we don't. There are still some surprises that happen, and there's still some fundamental physics questions that we don't understand the answers to. As part of my job now at the University of Minnesota, I get to spend probably about a good portion of my time actually looking at solar data, so using telescopes to measure things from the sun and analyzing that. And I also spend a lot of my time building instruments to work towards the next generation of technology and telescopes that can look at the sun. I also get to spend a lot of my time working with students, which I really love. It's fun. It's fun working with people who are discovering the excitement of this in the same way that I did. Then I sort of get to discover it all over again because I get to live vicariously through the students. So I think with that, since that's probably about my 5 minutes, maybe I'll just stop there and then you can ask me later about any parts of that you want to know more about.
Thank you, Lindsay. All right, next I will give the floor to Christopher.
Hi, can everyone hear me okay? Awesome, thank you. Good afternoon, everyone. My name is Christopher Gosch. I am a guidance, navigation, and controls engineer at Northrop Grumman now. To give you a little bit of background on me, I've always been interested in airplanes, rockets, things that fly. I've always thought that stuff, space, astrophysics, that kind of stuff is always really cool. So I knew from a pretty young age that I wanted to go into something in that general field. And it wasn't too long before I figured out that aerospace engineering was a really cool career option. So I started at the University of Minnesota in 2012 pursuing an aerospace engineering degree. I took an excellent seminar with Dr. Flaten in high power rocketry, which was really, really cool. We got to build and fly rockets. I learned a lot. And it really kind of helped me build, I'll say, a real passion for the practical side of things outside of just the classroom and the courses that I took, which were also very interesting. And through that, I also got involved with Dr. Flaten doing the high altitude ballooning research work that he does. So I worked on his ballooning team all 3 of the summers after my years in college here, and learned a lot of really good practical skills. I got to play a lot with sensors and microcontrollers and that kind of stuff, and really learned some very hands-on engineering techniques that and how to solve problems, how to get things working, how to work with things in a very real sense, more than just what you learn in the classroom. And that's knowledge that I was able to apply very, very well when I first started my job. I started working with, at the time it was Orbital ATK, now we're part of Northrop Grumman, here in Plymouth, Minnesota, working in advanced systems developments back in when I graduated with my bachelor's degree back in 2016. And I've been working there ever since, and I get to do a lot of really cool work there. So my job basically entails taking systems from design concept, basically an idea that someone has in their head, and we've got some money to go develop it. And we're going to take it from just that concept to a functioning prototype. So a lot of work in trade studies, a lot of work in modeling and simulation, and then as you go along, a lot of work in system integration. So I really enjoy my job because I get my hands dirty with pretty much the entirety of aerospace engineering. I do a lot of aerodynamics work. I've done wind tunnel tests. I do CFD, that kind of stuff. But then I take those kind of raw data components and I put them into physics-based models in the MATLAB and Simulink environments. And then we use those for predicting system performance, developing our guidance, navigation, and control algorithms, and really just kind of understanding how the whole thing fits together. And then the last step, which was really cool, and one of the first things that I did is taking those models and then integrating them with real hardware in things that we call processor and hardware in the loop systems, which are designed to be basically system integration and test platforms. And that's an area where when I first started my job, that's one of the first things I was doing, and I was really able to leverage the stuff that I learned working for Dr. Flaten doing the high altitude ballooning projects. So that's just a bit about me. I'll hand it back for now. Thanks.
Thank you, Christopher. And Rachel, if you could give us a short bio.
Absolutely. Well, first off, thanks for the opportunity to speak with you today. And really, potentially an opportunity for those of you that have not had the ability to interact with really anyone from the more developmental test side of the community. So more of the end user focus, taking kind of after Chris, as an example, gets done kind of with his aspect based off of the research that Lindsay did from a theoretical perspective of actually how do we actually bring concept to reality to field this new device, new component, new system, etc. So one of the things really I thought was pretty interesting. So getting into the flight test community, it's not just pilots, right? There's a whole team of engineers as well, flight test engineers, test conductors, test directors, your discipline engineers as well. And also the reality that although I happen to work for the Air Force, not necessarily everyone is military. A lot of government, civilians, and civil service, as well as your defense contractors, are all part of that team. So happy to answer any questions related to that. So graduated from the University of Minnesota and commissioned through ROTC, did what I would like to call the victory lap, being able to work with demos for about another year to get my master's done, which was great. And then went off to active duty Air Force and actually flew the A-10 Warthog operationally for 3 assignments. Had applied for and was thankfully selected to attend Air Force Test Pilot School at Edwards. So I was there for a year of school. And then after that, stayed at Edwards and actually transitioned to the F-16. So flying all variants of the F-16. So everything from your analog flight control systems, your digital flight control system jets, all the US variants, as well as our foreign military sales variants, doing flight tests on that. And then transitioned and added on the F-35, and not just the A model, which is what the Air Force flies, but also the B and the C model, so the Marine Corps and the Navy variant also. So pretty great experience there. And then recently transitioned off of active duty and full-time in the Air National Guard with that. But really from a developmental test perspective, the focus is really that executing that safe, secure, effective, and efficient kind of build-up approach to collect the data to really validate a lot of the models that Christopher had kind of alluded to as we are developing these systems. So then really ensure then proper not only just utilization of whatever system or weapon it happens to be, but then also really looking to mature that technology for the end state customer with that. I think I'll end it there before I just keep talking about the cool things you can do in flight test, but hopefully you'll have a couple questions I look forward to answering.
All right, thank you very much to all 3 of you. So what we want to do now is open it up to everyone here, students, faculty advisors, to ask our 3 panelists questions about their path to where they are and the advice they may have for students who are in the STEM area. Actually, let me kick it off and let me ask this question, and all 3 of you, if you can give us a short answer. What advice do you have to students that want, again, to pursue a STEM career once they're done with their undergraduate degrees? Or what they should be doing now to get into a STEM area that they're passionate about?
So I can kind of kick things off here. I will say the biggest piece of advice that I both got, and I realize with hindsight that that's really important to have, is just having some practical hands-on experience. The classes that you're taking in a science or engineering degree program are great. You're going to get the background knowledge that you need to be able to do your job. But I think that the differentiator when we look to interview people, and I think that the skills that I recognized that I had going into my job that were really, really valuable were the practical hands-on experience type things that I got, doing ballooning with Space Grant, doing rocket team, doing all of those kind of out of the classroom technical activities where I was able to take the things that I learned in the classroom and then apply them to a real world system, right? I was able to do some aerodynamics modeling, and then I was able to actually build something and see how does it fly. Or I was able to, test out sensors in a real environment, see noise, see errors, see all of that kind of stuff, and see the impact that these types of things that you learn about really is. And the other part I'll kind of point out there is that you learn through these practical experiences, I'll say some good kind of more intangible skills from the perspective of, it's a little weird to say it, but you learn how to fail gracefully. So when you're working on a project, let's say you're working on a rocket or a satellite or something, and it blows up, or you fry something or something to that effect, that's an experience that you don't really get in most classes that you're taking. And part of being an engineer and succeeding professionally, it's not that you don't have those moments, it's how do you react to those moments, and how do you say, okay, what happened here? What went wrong? How can I fix this problem so that we can keep moving forward? So I think that's kind of my big piece of advice, is to get your hands dirty as a student in doing something that you find interesting as a part of your technical field. And I think that really helps you prepare yourself for once you get into the professional world.
Yeah, I can maybe go next. I have both a specific and a general comment. The specific thing, and this is maybe opinion, but I know there's at least some people on the call who agree with me. I would say try to get in as much electrical and electronics knowledge as possible. I think that this is true both on, say, the physics, astrophysics side, so as many E&M classes as you can take. And I think that it might be true to some extent on the engineering side, as many electronics classes as you can take. Sometimes people tend to stay away from those because they are hard and this stuff is not intuitive, but it really is that way for everybody. And I think the more experience you can get with that stuff, the more it comes in handy later on. The next thing I wanted to say is that my general piece of advice would be to ask a ton of questions about stuff. When I'm working with students, especially in the research lab, the questions are really what I use to figure out where you are and what to do to help you get where you're going or where you want to go. I often use the analogy that as a student, really as a scientist, doing research is a little bit like wandering in a forest with a walkie-talkie and you're talking to your advisor on the walkie-talkie. If you don't really tell me much about where you are and what you're seeing and what questions you have, then I'm a little bit blind in terms of what I can suggest for where you should go next. But the more you ask me questions and give me information about what you're seeing around you, what problems you're having, what things you're not sure about, the more I can figure out where you are and kind of help you get to where you're going. And then finally, I'll just, I really want to reiterate what Chris said. I think having those experiences of things not working out are sometimes the most important things that happen to us. And early on in my career, I thought that when things didn't work out, I was going to be one of those people who, the whole thing fails and I'll come right back in the very next day and just do it again. And I won't even be fazed by that. Yeah, that didn't happen. When things didn't work out, I was really crushed at first. And it took me some time to get over those things when they didn't work out. So it's not necessarily about what you do in that moment, but it is about coming back and putting in the work over maybe a great deal of time to get back and try something that does end up working out. And it does work out in the end. Enough failures result in a success.
Absolutely agree with what Christopher and Lindsay said. The addition, I guess, would be is the importance of networking and continuing, kind of maintaining a black book, if you will, of individuals you've interacted with, because you never know when you're come across a challenge or a problem you can't solve. Is like, hey, I remember we had a conversation about this technology or this system. I'm going to call that person and see maybe if they can help us out as we try to work through that. But I think you're doing the right things, today too, by calling in and just getting perspectives from different individuals as you kind of develop what you think your desired career path will be.
Don't burn bridges. That's kind of what you're saying, right? All right. Anyone in the audience have questions that they want to ask our panelists?
Yes, Rachel, what made you want to be a test pilot?
This is always great because I think people might think I'm joking when I tell you this, but it was truly process of elimination for what I was going to do when I grew up. I was like, I was fairly much enjoyed like sciences and math, and in high school kind of was basically whittled it down to, oh, okay, I'll be an engineer. And then it's like, all right, that's broad. What kind of engineer? All right, aerospace, sweet. And I'm like, airplanes are cool, let's do that. I'm like, well, designing planes is awesome, but flying them would be cool too. So let's do that. And I was like, well, if I can be an engineer and I can be a pilot, wanted to be a test pilot. 100%. That was the train of logic circa probably sophomore year of high school, and it ended up working out.
Other questions?
I have a question for Lindsay. A lot of the people on the call right now are faculty members. When you were a student, did you cross paths with Space Grant at all? And I think you believe that Space Grant is valuable to you as a faculty member. Could you say some things about to faculty, how to benefit from this program, or what you would recommend?
Yeah, first of all, I definitely think that Space Grant is and has been extremely useful to several departments at the U in particular where I am, and obviously at a lot of other schools here too. In particular, I think that it has been tremendously useful in fomenting collaborations amongst different departments. So I work quite closely with demos, even though we're in entirely different departments, physics and astrophysics for me, and aerospace engineering for demos. And one thing I found is that it's not always easy to work across departments, but Space Grant is one of the things that is really helpful with that. And I suspect can also be helpful for working across institutions. So I think it's great that it encompasses so much. There's a lot of students working on very different types of things that all fall within the purview of what Space Grant can be relevant for. Again, no matter whether it's physics, astrophysics, aerospace engineering, in some cases, other types of engineering. I did not take part in Space Grant when I was a student, at least not to my recollection. Though I think a big reason for that is because Space Grant is very different in California than it is in Minnesota, just due to scale. And so I think there are some opportunities here in Minnesota because it is a bit more tractable and we can all get on the phone and get to know each other a little bit.
I actually have a question for Christopher too. Christopher, you never went away. Basically, I see you around. You're always helping. I appreciate this. I'm just curious if you can make some comments about what you've done that still connects you to Space Grant perhaps and to the university as your role in an engineer, and in particular how students maybe could find people like you or take advantage of that from the student perspective.
Yeah, so and a lot of that is helped by the fact I've got a job in town here. But yeah, one of the things that I view as a key value of mine is education, and I think kind of paying it forward is one of those things that I had some great mentorship experiences during my time in school, including from people on this call, but certainly others as well throughout the U of M and in other organizations. And I think any opportunity I get to be able to help out with that is something that I always jump at. So what I've tried to do is be, I'll say, as actively involved as an alumni as I reasonably can. And so, yeah, that means helping out with things from the Space Grant perspective. I've tried to help out as a judge with the regional rocketry competition that you guys host. I took part in that as a student, and so being able to kind of see things from the other side as a judge is a very cool and interesting thing. And it's good to be able to kind of provide that feedback and that experience level to the students in the competition now. Some of that also, I will say, is facilitated by I'm not really a grad student, but I'm taking some graduate level classes and will be eventually working to get my master's degree here as well, also in aerospace engineering. But yeah, so I try to do that kind of stuff, and then also through my role with Northrop Grumman, I'm kind of the liaison for some of the student projects, such that we get outreach funding from Northrop Grumman, my employer, to projects like I know we did sponsor the rocketry competition a couple of years ago. We try to sponsor student teams within like the aerospace department, for example, and all of that kind of stuff. So I think that's kind of my perspective of trying to help out these institutions, which helped me to get where I am today. It's something that's core to my values. And I think it's something that if you're a student, once you're able to go out and get a job, it's certainly something that you can do as well, right? You can try to petition your employer if you got some sort of an outreach funding program or something like that. You know, there's a lot of mentorship programs out there. I serve as an engineering mentor at the high school that I went to. There's a lot of good opportunities out there. You just kind of have to look around for them. So hopefully that answers your question.
Yes, we really appreciate it. And frankly, this is just a note to faculty. This is one of the reasons Space Grant tries to encourage you to keep in touch with your graduates after they've left your institution, because they have things to offer.
So I also have a question for Chris. You talk a lot about the benefits of you know, Space Grant as an undergrad, getting your hands dirty. What's maybe one thing that looking back you wish you would have been exposed to in Space Grant that wasn't in place when you were involved as an undergrad?
That's a really good question. I think the one thing I will say is there is certainly a difference between working in an academic environment and working in I'll say an industry environment. And there are some things there mostly related to just what it's like to work for a large corporation that I probably would have been well served by. Technically, you know, I think I got some good kind of technical exposure through the work that I did with Space Grant. So I don't have anything I would say there. And some of that too, right, is depending on what you wind up doing, right? You know, there's so many different technical skill sets available. It's hard to say I could have, you know, if Space Grant had done this, I'd be better. I mean, I think that's a very esoteric question because you don't necessarily know what your job is going to look like. But yeah, I would say maybe a little bit of exposure just to kind of the corporate side of things, you know, things that we have to deal with in terms of budget and schedule. I know that those were aspects of things that we dealt with, but it wasn't to the same level as what we have in industry.
So I have a question. You know, I work at a liberal arts college, and I think my students sometimes have a stereotype about the aerospace industry. And you know, when I meet people, I find them always to be more diverse and interesting than, say, would have fit into the stereotype. Do you have any suggestions on things I could tell my students who, you know, might kind of be a little bit nervous about getting into working for the word defense contractor or something like that? Did that make sense?
I think, are you asking me or?
Actually, I'm asking the whole panel. I think that there are just some stereotypes, and I know that sometimes I've listened to my students, and I think, you know, there are all kinds of people, and you know, you should maybe be a little bit more open-minded. You know, but they have, you know, their particular viewpoint or political starting point. So just kind of curious how I might work to break down some of those barriers, because they're great careers and great people.
Let me add to your question, Benjamin, and then Ben, so that way, and I might direct this at Rachel. When you were a test pilot at Edwards, is it all Air Force, or is there a huge component that are civilian, that are doing civilian flight testing? And isn't the National Test Pilot School out there run by civilians and not the military? Can you add to that as well, a little bit along those lines? I guess is that kind of where you're going with it, Ben?
I'll try to take a swing at the diversity aspect. And so to answer your question, yes, National Test Pilot School is run out of Mojave, which is in the vicinity of Edwards. It's one of, it is, I believe it is considered an affiliated institution. You have Air Force Test Pilot School, Navy Test Pilot School, and then you'll have the Test Pilot School in France, and then another one in Great Britain are the four, and then National is like the fifth, if you will. But I think, like I was alluding to prior, there's plenty of government civilians and contracting representatives that are not necessarily military that are an integral part of the developmental team. And to be honest, everything from like your integrated master schedulers through your technical editors, you know, for as much as possible, you know, with the technical writing aspect, there's still that art, if you will, that graceful art of relaying that information. So I'm not sure if that's quite hitting on exactly what you're trying to get us to dig in on, but I will say that there's a number of opportunities in a number of different career paths that all kind of come together, as part of that team concept.
I also had a couple comments, and Ben, I apologize, this is probably just telling you some things you've already thought about, but it can still be useful to hear it as what are other people doing with that. I definitely agree to some extent with what you said about sometimes people have a really a stereotype in their mind of what an astrophysicist might be or do for their job or look like, and same with an aerospace engineer. And I will say that in my line of work, I meet tons of people all the time who do not necessarily fit the stereotypes of what people think about. So I think that those are stereotypes and that they're not necessarily correct. I like to do career spotlights in my classes sometimes. So just a slide at the start of the class that shows off one person who has a particular career that could be a career that people in that class might eventually end up in conceivably. And that gives the opportunity to show off people doing cool stuff that's related to this. And you choose to highlight a variety of different people in that way. You could also choose to highlight a variety of different careers in that way too. If I were thinking about that issue of like, well, what kind of work can one do if one works for the Air Force? For example, I could highlight colleagues of mine who do solar astrophysics for the Air Force because that's something the Air Force cares a lot about. Space weather affects us. It affects the near Earth environment. It affects the Earth. And so that's the type of job that people might not have thought of in association with the Air Force, but there are people who are doing what I do, but working for the Air Force as well. So that might be a way to do it.
I think the last point I can add there is that just because some company is called a defense contractor, right, and that is potentially a core part of their business, that like was said earlier, right, that doesn't mean that's all the work that was done. Yes, I work on the defense side of the business. Let me make this clear, right? Part of working on the defense side of business means certainly that, you want to be, I'll say, patriotic, but that doesn't mean a political thing, right? I want to make that point abundantly clear too. So it's not like everybody is all political or something like that. We are all there because we feel very strongly that the systems we work on help the war fighters, and that's something that we place a tremendous amount of value in. But that is one small part of our company, right? Northrop Grumman is a very large company that does a ton of work. So yeah, we're working on certain systems here in Minnesota, but there are folks that are building communication satellites, science payloads, anything you can imagine in the aerospace industry. We fly resupply missions to the space station. We're doing part of the Artemis program as well, right? We're helping out with Blue Origin on that lander. So it's not just because you're working for a defense contractor, it doesn't mean you're just building, bombs or missiles or fighter planes or something like that. There's a real diversity to the work available at these companies. And these companies are very welcoming and open to anyone who wants to work for them. So if you're a technical person who has the talent, that's what we're looking for. Is we're looking for smart people who want to do good work. So hopefully that helps a little bit.
Yeah, no, those are great answers, and I appreciate that framing of patriotic rather than political, right, would oftentimes help.
I maybe have a question. This might be a little bit more specific to Lindsay. So I was wondering if you kind of always knew that you wanted to ultimately end up in academia, or if you were kind of like debating that between industry as well. And if you have any advice on that.
Yeah, that's a great question. And I did definitely weigh that career choice at one point. I think the time in my life when that most acutely came up was the last year of my PhD at Berkeley. And then there was the whole, well, what am I going to do next? And everyone kind of likes to avoid that question because you feel like you're planning out the rest of your life. So that last year of my PhD, I needed to seriously address the question of what I was going to do next. And so I knew some things about academia already because I was already there. And I knew that I really liked doing that and that I liked the work that I was doing. So I knew that that would be a good option if I wanted to keep doing that. But it's really important to not just keep what you're doing what you're doing because the momentum is there. I mean, you need to scope out what are the other options as well. So that you know where the paths could lead and you're not just staying in a thing because it's already what you're doing. So I also looked at a lot of industry jobs, particularly related to some of the technology, the detectors and cameras that I had been working on as a grad student. And I kind of got as far as making some connections at companies, talking to people to find out what sort of thing they did, investigating what careers might have. And for me, when I examined those specific career options, you know, I sort of felt like, yes, I could see myself being happy doing this. But for me at that time, it didn't really have the same spark as it did to actually do astrophysical investigations. So that's how I knew that, you know, that aspect of things was important enough that I should keep doing that and stay on the academic track rather than going a different route. You know, that being said, if I had gone a different route and had gone to work for one of those companies, I have no doubt that I'd be happy and would have found a great career there too. So it's not necessarily something where there is just one answer to it.
Sure. Yeah, that's helpful. That's good to hear. Thanks for your advice and input on that.
So Rachel, you have made a transition. I don't know how big of a transition this really is from Air Force to Air National Guard. Can you tell us a little bit about how that came to be and what you see the future for you career-wise?
Sure. So it was primarily just based off trying to, you know, fill some, I guess, needs or desires from a kind of taking myself off of the kind of career trajectory I was on to be able to focus on family for a little bit more. So really was thankful for the opportunity to work here. As far as Air National Guard, I guess Air Force Reserve as well, and this will be similar across all of the services. Just allowed a little bit more stability, if you will, from a location-based perspective, which was something I was just desiring from a kind of mid-career type move. So with that, it's also allowing me some opportunities to have some extra time. So been doing some additional consulting, which has been enjoyable, you know, having stepped out away, you know, from the day-to-day flight test activities back to really kind of like a fleet type unit. Still wanted to be able to, you know, kind of engage at that level. So that's been extremely enjoyable. I've also, you know, considering potentially going back to school again for fun, I guess. Or at least it's what I remember it being. It's probably different in your 30s than it is in your 20s though. So that's really just a kind of the opportunity for me to still continue to surf, which is something I wanted to do, but then also be able to do that in a location that was suitable for what I was from a family perspective.
Thank you.
I have a question. So this is for all three, I guess. But what specifically have you learned about conducting research or like in your field after you graduated that could be applied to undergraduate research?
I'll take a chance on that one first. Is really the ability to take the theoretical concepts and bring them to reality. I think, you know, when I, you know, reflecting back, you know, on kind of my undergrad experience, as you're, you know, being the fundamental building blocks and you're being taught the theory is to be able to go and extract that book knowledge, if you will, and actually practically apply it was significant, I think, challenge that not everyone is always successful at right away. So that really just practical application of theory was extremely useful. And I think we saw it through some of maybe the senior design type courses, where it's kind of some of the first opportunities as you're as you finished up your undergrad. But really that was kind of, I would say, one of the things that I think pays dividends throughout your career?
I kind of have so many responses to that I'm not sure which one to respond. So maybe I'll again go with a sort of general one, which is that I think a useful thing to know is that it's very, very normal and in fact even desired when you feel like you don't really know what you're doing. Because that is what a lot of us are doing for careers. We're working on things that are really forging new territory. We're tackling questions that have not been answered. There's not a solution set textbook out there that has the answers to the questions that we're working on. And usually, most of the time when we tackle a certain problem, it is not clear what we should do to tackle that problem. Now, sometimes we can use templates. We can go to our standard tools like, okay, I know what worked with a problem last week, so let's try that one this time. But a lot of times it's just going to take very creative new solutions in order to solve something. So that situation when you're sitting there with what I call the blank page of doom and you're not sure what to write on it, when you think to yourself, oh my goodness, I have no idea how to handle this problem. That's okay, that's normal. That's the situation that we work a lot in, and that becomes a lot less distressing over time. Over time, you recognize that as an opportunity to write down what you want on that page and vet it, rather than just a blank page where you don't know how to take the first pencil stroke. So I wish that I had known that back when I was a student.
So I'm going to point out a couple of very specific things here that may or may not be applicable to everyone, but I will say I learned a lot about coding and writing some, I'll say, basic software and some of that kind of stuff when I was doing my undergrad and working for Space Grant and all that. But the amount that I've learned in terms of how to effectively write good software, specifically MATLAB code, building good Simulink models, all of that from working from people who have been doing this much longer than I have. That's something that I think has been that's something that would have been very useful for me as an undergraduate. Likewise, I think kind of, I'll say, a higher perspective on things. And what I mean by that is, when you're in an individual course, right? Let's say you're taking a class in aerodynamics or a class in classical controls or something like that. You're really looking at the problems at kind of the very specific, how do I solve this individual piece of the problem versus how do I think about this from a top level? Here's the system, and how do we get all of these different pieces to fit together in a system? And that level of kind of systems level thinking, it leads you to consider factors that you may not be thinking about otherwise. So, for example, in the controls domain, right, I might be able to come up with an excellent controller that solves my problem and gives me the best flight characteristics I could possibly want. But I might be doing it in such a manner that there's no way we could ever put it on a processor and run it in real time on an airplane. So I think those kind of things are things that you learn with experience. It's not something that can necessarily be taught super easily, but it's something to maybe think about as you continue through your undergraduate career. It's just how do the individual things that I'm learning here potentially fit into something larger than what I'm looking at right now.
Thank you.
That made me think of something. A quick story before we're in that time is when developing the F-35 flight control system, the engineers actually took the phugoid out of basically you're like, well, why would we ever want a phugoid? It's out. And then the pilot, we hated it because it didn't fly like an airplane. So the pilots, still have, that kind of still sense of like an airplane should feel probably right about this. So they actually had to code the phugoid back into the flight control model to frankly just satisfy us test pilots. So it would be like, okay, it flies like an airplane now, we're good. It's just an anecdotal story. I think that's quite applicable to your comment.
All right, we're at the bottom of the hour. Is there like one, maybe we could take one or two more questions and.
I have a question.
All right.
So I'm curious to know how to like not be discouraged. This is a question open for everyone, like all the panelists, because the school year has been kind of hard, but I still want to pursue like my degree program, and there's been moments where like it's been really rough and things don't really go as planned. So I'm not sure what's the best way to kind of go about that.
If it's okay, can I take the first try at this one? Okay. Yeah. So first off, I want to say that I think what you're experiencing right now is really common. I'm hearing this from a lot of students, and that's not to say it's negligible. Oh, everybody's experiencing it. It's just to let you know that I think a lot of people around you are probably experiencing that as well. This has been a hard semester for everybody. And there's so many things being compounded all at the same time. There's the pandemic, there's online learning, there's new awakenings as to what the social justice situation is in our country. And all of these things are just coming together at once. And then at the U in specific, we also have spring break later than usual this year. So I'm really hearing this from a lot of people. So the first thing is to tell yourself that that is normal and that's an okay way to feel. The thing I would tell you about that is that when you're feeling a lot of stress, you want to use that to convince yourself to work hard, but you don't want to use that to push yourself so hard that you're past your breaking point. So what I always say is that when you're staying up late trying to finish that one last homework assignment, study for that last midterm, allow the stress to push you to do that. But don't let the stress just beat you up for not being a perfect student. Nobody is. And usually, statistically speaking, students are usually doing a lot better than they think they are. I think that's the case generally on average. I also like to tell people that when things are getting really tough and you're not really sure if this is the right thing for you or not, there are always decisions you can make. I mean, you don't have to stay doing it, but I always tell people to never quit on a bad day. When it's that really tough time, when it's very late and those negative voices are talking in your head, that's not the time to make a decision on things. When you're well rested and have an opportunity to really think things over, that's the time to kind of make the major decisions about things. So just keep putting one foot in front of the other, keep doing the next thing that you can, and you will get through it.
I would say just talk about it. Talk about it with your friends and those in your trust tree, your whoever they friends, family, peers, staff. Part of being resilient is not necessarily keeping all the challenges and struggles to yourself. And it'll be amazing, I think, not only just for the three panelists and the staff on here, we've all experienced failure many a times. And it was, to be honest, knowing that other people have also failed kind of helps a little bit, right? It still stings, don't get me wrong. But I would say is you're not doing this alone, and there's other folks that be there to support you. But I would just say talk about it and be open and honest with yourself, and as well as with others, and you'll press through.
I think those were really great points, and I will certainly echo them. I'll just add, right, I completely understand that where you're at. It's really, when I was doing my undergrad, the spring of my junior year was a really rough semester. It was really tough. The classes are really tough. I don't know if you're an aerospace major or not, but I think there are just times when it gets like that, and it is really stressful and it's really difficult. And I think there were certainly times when I had to be, metaphorically talked off the ledge, and that's where, being able to lean on your friends, your family. There were more than a few times where I'd call my mom and my parents would come down and they'd take me out to dinner. And it's really amazing how much a really good meal, getting a good night's sleep, some of that kind of basic stuff can help you with that stress level. But then, also having your friends and being able to use them, to lean on them as well is a really valuable thing. And I know that's something that certainly can't be good because of the pandemic, right? I mean, that's robbed us all of so much of that kind of support systems. So I think that's important. The last thing I'll just say is keep your end goal in mind. You know, I knew when I started at the U, right, I knew I was going into aerospace engineering. I knew it was going to be difficult, and I knew there were going to be times where it was going to be really, really hard. But the thing that always got me through was that I knew that when I was done, I was going to have this degree. I was going to be really proud of it, but it was going to allow me to go out and start my own, or it was going to allow me to go out and get a job doing something that I really, really liked. And that's something that, you know, once you get to the other side of that and you get a job like the job that I have right now, where I really love what I do for a living, and it's not perfect, right? But being able to go to work every day, do something that I really enjoy, and I feel a great sense of purpose out of, it makes all of that much more worth it. So certainly keep the end goals in mind as well. So hopefully that helps some.
So Demos, why don't we wrap this up and then we can finish our conference with the announcements.
All right. All right. So first of all, I'd like to really thank our panelists, Lindsay, Christopher, and Rachel. Thank you very much. This was really good and great. And I guess I got to do this. All right. And with that, I think I'll hand it over to you, James, to do the announcements.
Sure. So why don't you just stop this recording and then actually start the recording again, and we'll just record the announcements as a separate clip. So don't just pause it, stop the recording altogether,